Alright guys, here we go. We're going to learn today about Introduction to Chemical Bonding, which is a hugely important aspect of all chemistry, and it's going to be the baseline for everything that we're going to do in this unit. Now, you might notice that we are one person shy today, and that is because Mr. Harkins does not feel good. In fact, he has no voice, which really is kind of hard to then talk and teach things. So he's going to be gone today. So, sorry, Mr. Harkins.
Yep. So anyway, we got to start by recapping what we call the octet rule. Now, first of all, chemical bonding. This is the act of gaining, losing, or sharing electrons in order to get a full outer valence orbital.
That's the last orbital,
the very last one, yep. Now, the octet rule states that atoms tend to combine in ways that give them 8 valence electrons. So the reason the reason atoms bond is because they're trying to get that full outer shell with 8 electrons there. Okay? That's why things react, because they're trying to get that full outer shell.
If they already had a full shell, would they react then, or would they not react?
Generally, they will not.
Oh. So, like the noble gases that all have 8 valence electrons, they're not really going to react too much.
Right, right. So anyway, atoms are most stable when they have 8 electrons in their outermost shell. One exception is helium. Has a full orbital only when it has 2 electrons, because it's just in that first row, remember. And
So
that first shell only has 2 electrons in it. And then atoms become stable by bonding in order to actually gain those 8 electrons. So, Mr. Harkins, would you like to take the next slide? Oh, wait. I guess you can take it, Mr. Black.
All right, I'll do it. Okay. So, gaining or losing electrons, how do you figure it out? Like, how are we going to know are they going to gain or they're going to lose? Well, it's actually not that complicated. One of the easiest ways you can look is there's this thing called the electron rule. And basically, atoms that have 1 to 3 valence electrons will tend to lose them to become more stable. And if you notice, if you look on the periodic table, the metals all tend to fall in that category. So another way to look at it is if you're a metal, you're typically going to lose those electrons and become positive. And then as you're doing that, you're going to form bonds. Atoms that have 4 to 7, and usually we say 5 to 7, but we'll include 4 for this, they tend to gain or share electrons to become more stable, therefore becoming negative if they're an ion or not. And if you notice, the vast majority of those tend to be nonmetals.
Right. So the first type of bond, and as Mr. Black was saying, this is on the right side of the table. I'm trying to do it the way that their perspective is. That would be their right, I think. Anyway, so a covalent bond is where 2 atoms actually share electrons. So this takes place with atoms that they have almost a full valence shell. So think of it as an atom, 2 atoms, they get together and they're like, hey, I almost have a full shell and you almost have a full shell. Why don't we share a few? And then we could both have a full shell. And that's what a covalent bond is.
Sharing is caring.
Yes. Now this can result in solids, liquids, or gases. They are weaker than ionic bonds, which Mr. Black will explain in a minute.
Yep.
And this occurs between nonmetals. So all that stuff on the right side of the periodic table that is not a metal, if they're bonded together, it's a covalent bond. Okay? Also remember that hydrogen is a nonmetal.
So for example, to say that. Can you read my mind or something?
I'm pretty good at this stuff.
That's
so
creepy.
like water, for example, is 2 hydrogens, 1 oxygen. So since they're all nonmetals, I don't even have to look at the chemistry of the object. I just know because it's all nonmetals, it's a covalent bond.
There you go.
All right?
And once they share, they become happy.
Yep, and once they share their electrons, they are happy.
Yay. So the other main type of bond that we're going to learn about is the ionic bond. And this is a bond in which electrons actually get transferred from one atom to the other. And the result is you get an attraction of charges that causes them to form a bond. So you might recall us talking about positive and negative ions before. Positive ion, you've lost an electron, so you have more protons than electrons now, so you're positive. Negative electrons, you've gained an extra electron or 2 or 3, and now you have more electrons than protons, so now you're negative. And you've probably heard before that opposites attract. So positives like to attract to negatives. So what happens is one atom gives up an electron, in this case the sodium atom, to the chlorine atom. Sodium becomes positive, chlorine becomes negative, the 2 are attracted and they form a bond. What you get is a very strong bond that forms little crystals. They're called crystalline solids because of the arrangement that they make. They kind of make little boxes and it's nice geometric shapes and it works perfect. It's a much stronger bond because the actual transfer of an electron is a tighter, stronger bond than just sharing an electron is. And this typically occurs when one atom loses and the other one gains. And normally we say it's a metal and a nonmetal that does this. That's the easiest way to look at it. So one from the left side of the table will bond with something from the right side of the table. Remember, when we say left and right, we're talking about that little staircase that we artificially draw as your dividing line.
So in this case, you're saying that sodium chloride, I can even tell without looking at all the electrons because sodium is a metal, chlorine is a nonmetal. And just by seeing a metal and nonmetal bonding together, I know that it's an ionic bond that's forming that compound, right?
Perfect. Yep.
All
So
right.
if you think about it real quick, covalent bonds, look at the formula. If it's two nonmetals or two or more nonmetals, you're covalent. If it's a metal and a nonmetal, you're ionic.
Okay.
Nice
I
and
think
easy.
that's it for today.
All right.
Have a good day.
What do you think,
Hope
Mr.
you-
Harkins?
I hope he's back soon.
I hope me too.
I miss him.
He's funny.
All right. Bye.
Peace.